Welcome everyone. This is Professor Ma, and this is a summary to the first sections on the review on the algebra. In these sections, we're going to go through review the algebra, and in particular, we're going to go through solving most of the equations, manipulating expressions, all those techniques that we are going to use, including absolute value equations. Let's start. Expressions. So here's example that expression formula calculating how much money we're going to pay to order 100 pizza. In particular, this is the formula. Okay, and this we call expressions. And what's important about expressions is expressions are used basically to calculate output. What's going to come on if I put in an input 100 in this case. Okay. These are called algebra expressions versus sine, trig functions, log of x, exponential function. Those are different classes. So the most of calculation we're going to do in these reviews, of course, algebraic. And in particular, polynomials are these types, algebraic. Important. Then the fractions of polynomials. So in particular, here's a polynomial, okay, and here's a fractions of two polynomials. Okay, here's a third-degree polynomial. Notice the square root of 3. Oops, the square root of 3 is a number. The square root is not over the x. So the second formula is a fractions. And these are one of the basic operations in polynomial is subtraction. I just want to point out in this subtraction problem, you need to put it in a bracket, and you can then resolve the negative sign by changing signs everywhere. Okay, just a reminder. And there's another way to do is move the minus sign in, then you multiply it out, and then combine, you get a same answer. Okay. If you didn't get the answer right, check the sign change. One of the most important steps we do to expression is we factor. And so we write it down, write it into two as a product. Okay, and these are some factoring formulas. So for example, x squared minus 4. This is the formula, and if I factor, it's x plus 2, x minus 2. Okay, I can even if I use the and this is called the factor form. Very important word. A lot of things we need to do. We need to change the formula into the factor form before we do anything to them. Here's an example how to factor the third degree using the formula. You can see how it turns out. Okay, and usually if this part cannot be factored any further, so this is as is usually. And what do we factor? Okay, and a couple of very important rules. Okay, here, what called a sign product rule and a zero product rule. The sign product rule says if I know the signs of the factors, that I know the sign of the product. The zero product rule says if I know the product 0, then I know one of the factor must be 0. Okay, so here's an example of the sign product rule. Okay, for instance, the problem is asked us to put 2.03 into these polynomials and then find out what the sign is going to be. It didn't ask what the number is going to be. It asked for what's the sign, whether it's going to be positive or negative. Okay, and here's a polynomial in the expanded form. Okay, and of course the example is made up so that if you factor, this is the factor. I just want to point out that it's a lot easier to check the sign by plugging 2.03 into the factor form. Okay, in this form, it's a horrendous calculation. But in the factor form, it's easier because now I can determine the sign. It's going to be plus sign for the first parentheses, plus sign for the second parentheses and so on and so on, and then say, oh, I'll count the number of negative signs minus. So, oh, therefore the result is negative. Okay, so that's what the sign product is. If I know the sign of the factor, that I know the sign of the product. We're going to use these to solve a whole host of graphing problems that's involving sign chart in the next section. Okay. Fractional formula. Fractional formulas like these are called expander form. Okay. And if I were to factor the top and bottom, it's called the factor form for the fraction formula. So in one particular things about the factor form is I can cancel factors. I get an expression that's almost the same, but not quite. In this case, I get the simplified or the reduced version, which is almost the same as that one, except at one location. X equal to 1, I could plug it into the formula in the reduced form, but the 1, I may not plug it into the top one because it will be undefined over here. So this is the difference between the reduced form and the non-reduced form of a fractional formula. Okay. How do we handle fractional formulas? We're going to use a lot of the following techniques. We're going to use the least common denominator to do the following things. For example, okay. And it's going to call the multiply the LCD methods. Okay. And I assume that you know how to find LCD. If you're having problem, question about how to find LCD, look at the Math 260 sections on least common denominator to review. Okay, so and the multiplied by the LCD method based on the following things. That is, if I have, give you an example, 3/5 times 20. Okay, 20 of course is 20/1, and if I can cancel the factors into 20. And then the first thing I do is I do the cancel, then I multiply the result, which is 12. So, and we're going to use these ideas, this way of writing, tracking the formulas a lot in the PowerPoint. So for example, common denominator over here is 48. And so from here on, it's basically bookkeeping methods. And the way that we're going to do it is we're going to do the following things. We're going to multiply 48 over 48. We're going to multiply by 1. But the actual multiplication is only for the first 48. Multiply the 48 into the 3 terms. Then you have a lot of cancellations, like what we just did. Then you collect what's left over. It sits on the other denominator 48, which we haven't touched, and that's the end result. So this is just a way of tracking. And here is manipulations of rational additions. Kind of messy, but the way we going to simplify these is we're going to multiply the entire problem by then divided by common denominator. So in other words, I'm going to multiply these things, find out what the numerator is, and put the answer back on the common denominator. And so then this is the cancellations. And then I went out with this binomial multiplication subtractions, like first example. Simplify whatever this is. This belongs to over the LCD. So the answer, now I put the LCD back as the original common denominator, 3 parentheses back. And this is the answers. Okay. So this is just a way of tracking things that in the PowerPoint. What else we're going to use the LCD for? This is a step we're going to do in simplified difference quotients. It's clear these common complex fractions to what degree, to the degree where this h will be canceled out. How? Oh, use the LCD. What is the LCD? Well, it's x plus h times x minus h. Again, we multiply this problem by the number 1. Okay, x plus h over x minus h is 1. So except comes in top and bottom. And then I multiply the top to the top. I multiply this. I leave this alone. Oh, give it a different color. This part, don't touch this part. Okay. And notice what happened. After cancellation, that's what I get. And then what's left will be the h, only h is on top, and then they cancel. That's how it's simple. You will see this process later on again. Another things we do with expressions is we use a conjugates. In particular, we use it to rationalize the numerators or denominators. And here, what does the word rationalize? In particular, it means change this expression to something else so the top part has no square root. Okay, and of course, you change the square root has to go somewhere. So in this case, that the square root will be going on the bottom somewhere in here. Just do this change, and the way we do it is. Oh, by the way, this problem, the h will be canceled, as similar to the last problem. We use the conjugates because conjugates square out the square roots, and that is simplified. And the h pops out in the numerator. They will cancel with the bottom h, being 1, and this is the simplified version. This is another technique we will use in a type of algebra we're gonna see. Okay, this is a simple version of it. Okay, so these are the stuff we do to expressions. Next, let's talk about what are equations. Okay, remember the expressions we have about ordering pizza. Okay, suppose that the doorbell rings and the bill is $810. Okay, and so pay the delivery person $810 and then say, wait a minute, how many pizza did they order? Okay, so we make this equation. The A times x plus 10 is equal to the $810, the output. And the question over here is what is the input? And we backtrack back, take away the $10 delivery charge. Okay, then each pizza costs $8 divided the 800 by 8, so I get, oh, I can backtrack the x is we ordered $100. Okay. In other words, equation I use to backtrack the input, okay, for the known output. If I know the result, what was the input to make this comes out to be true? Okay. And here's summary of the equation we are going to solve. Okay. Basically, every equation we're going to solve, we have to reduce it or somehow change it into a first degree equations like this, like the one we just had before the AX. This is the first degree equations. X is first degree. Okay, so again, back to solving the equations, we have to get back to the first degree equations or second degree equation. Even if we get back to second degree equation, basically we'll have to get back to first degree equations. And one way or another. Okay. And how do we solve second degree equations? Well, we're going to try factoring first. Okay. Like I'll give you a very fast example. Okay. How to solve x squared minus, just to remind you, and then we say this is x plus 2, x minus 2 is 0. Aha, the 0 product fact. So only way to make this happen is to make x equal to minus 2 or make x equal to 2, which will make the parentheses 0, the first one, and then the product is 0. So in particular, 2 will make this parenthesis 0, and the 0 times anything, I don't care what this is, it's going to be 0. So this one, check. If I cannot factor, then we do the quadratic formula. Okay. This quadratic formula. Okay. And in particular, the part that's important about the quadratic formula is the b squared minus 4c. And so you can read these, tell you something about the roots. One other type of equation shows power equations. And how do we solve power equations? We raise power to both sides, the reciprocal power to both sides. The power we here raise is minus 2/3, so I raise both sides to minus 3/2. Why? Because when I raise the power to another power, I multiply, and this is going to give to me, it is going to give me x to the first power on the left-hand side. And the other side is the symbolically what I have to calculate with 16, which is square root and 164. And here's another example of that. So this is how we solve power equations. Radical equations. And some of the problems that we get into have to give rid of square root. And in particular, the longer ones, I don't want to, we have to do it twice, like these examples over here. What's the point of the example? To remind you how we square. In particular, this is not, a lot of mistakes happens here. Oh, let me square these, and square these. So I get an easy version, x plus 4 is equal to 5 of 16 is equal to 5x plus 4. Now, you can't do that. What is legal is square this entire thing. If the left-hand side and right-hand side are the same, then I can square the entire thing. Entire left-hand side, and that's going to be equal to the square of the entire right-hand side. That's what's called. Then this involves squaring two terms, which I'm going to use this formula. And we're not going to be able to get rid of both square roots. One of them will remain because of the rules, and they have to do it twice. We have to do it again, so we have to do this twice. So this example, I'll let you finish reading it. Okay, so for radical equations, this is how we solve for x. How about fractional equations? Oh, we use common denominator again to clear denominator. In this problem, multiply both sides by the common denominator. And then again, canceling, I change this into a second degree equation. Okay. So everything comes down to first or second degree equations. You have to get to, we know we're home safe when we see these equations, also square equations. Okay. Then lastly, the absolute value equations. The absolute value between two numbers. Okay, here's number x, y. Okay, let's say here's 3, here's 5. If I want to know the distance, if I'm a carpenter, I want to know the distance between 3 and 5, and the rule is the right-hand side minus the left-hand side. Okay, so right minus left. It's 5 minus 3, I get 2. But if I don't know the position, who's on the right, who's on the left, and suppose I just pull out two numbers, x, y, I want to know the distance, I don't know which one of these, and which one is on the left, which one on the right. So one of these will be positive, one of these will be negative. And to erase that distinction, I slap absolute value around. I say, oh, that just be the distance. Okay, so 3 minus 5, it's 5 minus 3. It's a distance between them is 2. This spacing 2. Okay. In particular, then the interpretation of these equations translate to the distance between the number x, whatever that is, and the number c has to be the number r. And this has a geometric meaning. Here, C is the center. The x has to be distance r to C. That means it's the 2 points to 2 sides. R distance away. The location are C plus R, C minus R. So this has a geometric interpretations. So this are the 2 points 12 units away from 7. So the 2 points are 19 and minus. So this equation shows up. Finally, we solve equations, and one of the things about solving equations is to answer the following 2 questions. If I'm giving a fractional formulas, what are the zeros for the formula, and what are the points where it's not defined? In other words, the domain. Okay, the domain are where they are defined. So if I can find where it's not defined, then that's a domain. And that, of course, is where the denominator is not 0. So for example, the 0 square, the top is 0. So when I'm plugging plus minus 1 into the formula, I get F0. But 2 and minus 2 is not defined. They're not defined. The formula is not defined. The domain is everything except 2 and minus 2. So, okay, these are the most of the algebra we will use. And have a good day. Okay, bye-bye. Bye-bye.